Okay, so today we're going to look at some stuff that's only a box on page 444 to 445 of your textbook. It talks about masses of reactants and products. If you were taking a chemistry class, this would be called stoichiometry. But we're not going to call it that. Okay, and we've already talked about turkey sandwiches, and everybody seemed to understand the turkey sandwiches. So it turns out that sometimes it's necessary to determine how much reactant is needed to make a certain amount of product. That's what we did with the turkey sandwiches. We saw how much turkey or how much bread we needed to make, say, 6 sandwiches. So the minute we start doing this with chemicals, people get confused. Okay, so there's a couple of things you need to have. You need the mole ratio of the reactants and products. You get this from the balanced equation. These are the coefficients. These are the numbers in front of the various compounds in the equation. Okay, so that's where you get them. Whoops. And you're always going to need these ratios. The other thing you're probably going to need, if the question says grams anywhere in it, if it says you have this many grams, how many grams do you want, is the molar mass of the compounds in the problem. So know that if the word grams is in the problem, you're also going to need the molar mass. Okay. There are 4 different kind of problems you can do, and they each use a certain combination of the coefficients and the molar masses. The simplest one you can do is a moles of reactant to moles of product problem. I'm going to do one in a bit. This is very much like the turkey sandwiches. That's what we did, was moles to moles. Moles of reactant to grams of product is a little more difficult, involves needing to know the molar mass of the product. Grams of reactant to moles of product involves needing to know the molar mass of the reactant, but not the product. And grams of reactant to grams of product involves needing to know the molar masses of both reactant and product and the mole ratio. Okay, so for each of these, we're going to be using a different set of steps. And I wrote them down as steps. I could give you a simple little diagram for them, but it might be easier just to see the steps. So we're doing type A, moles to moles, and we're going to be using this equation. 2H2 plus O2 gives you 2 waters for all of the problems we're going to do, all 4 of them. Okay, so moles of water for 3 moles of oxygen. To do a mole to mole problem, you take the moles of the reactant, then you look at the balanced equation and you take the moles of product and divide by the moles of reactant, and that will give you the moles of product. It turns out that these things, moles of reactant, are going to cancel. So if I have 3 moles of water and I want to know how much, 3 moles of oxygen, that's what I was given, and I want to know how much water, I take the given, I look at the balanced equation, I find the coefficient in front of water, which is 2, I find the coefficient in front of oxygen, there's nothing there, it means 1. Okay, so that's my mole ratio, moles of product over reactant. Moles of oxygen cancel, 3 times 2 is 6. And the only remaining units are moles of water. So you just follow these steps. Okay, for type B, okay, this is a little bit more difficult. To go from moles of reactant to grams of product, you take the moles of reactant that you're given. Again, you multiply by the mole ratio of moles product over moles reactant. Again, it's from the balanced equation. Balanced EQN, sorry. And then you multiply by the molar mass of the product. So my problem here, I started with 3 moles of water. I want to know how many, 3 moles of oxygen. I want to know how many grams of water I made. So I found the molar mass of water. It is 18 grams. So I'm starting the same way I did the other one. 3 moles of oxygen. Mole ratio, 2 over 1. 2 over 1 from the balanced equation. Multiply by 18 grams of water in 1 mole. Moles oxygen cancel, moles water cancel, and you're left with grams of water. So 3 times 2 is 6, divided by 1 is 6, times 18 is 108 grams of water. The very last one, I had intended to do C, we'll do C on the other page, is grams. I just, mixed this up when I was doing it. Grams of reactant to grams of product, you need everything. You need the mole ratio and the molar mass. To do this problem, you take the grams of reactant, you divide by the molar mass of the reactant, 1 mole over grams of reactant, that's dividing by the molar mass, multiply by the mole ratio, moles product over reactant from the balanced equation, and you multiply by the molar mass of the product. So here my problem was 32 grams of oxygen. I divided by the molar mass of O2, which is 32. That's same mole ratio, 2 waters to 1 oxygen, times 18 grams per mole. That is giving me 36 grams of water. So the problem here was 32 grams of O2 is going to make how many grams of H2O? Where I didn't actually even write down the problem. The last one is actually type C, and it is a little easier. It's grams of reactant to moles of product. To do that, you take the grams of the reactant, divide by the molar mass of the reactant, multiply by that mole ratio. The mole ratio is always in there. We're still using this equation, O2 plus H2 gives you 2H2O. And I have 16 grams of oxygen, and I want to know how many moles of water I'm going to make. So I write down the 16 grams of water. Now I'm going to divide by the, 16 grams of oxygen. I'm going to divide by the molar mass of oxygen, which is 32, 16 plus 16. And then I'm going to multiply by the mole ratio of the moles of product, water, over the moles of reactant, oxygen, which is 2 to 1. 16 divided by 32 is a half. This is my starting amount, molar mass of oxygen. So I have a half. The grams of oxygen cancel. I have moles of oxygen. Moles of oxygen cancel here. So take a half times 2, and my answer is 1 mole of water. So we're going to practice on some of these. It's probably a little bit on the hard side, but if you take chemistry next year or the year after, seeing this once will really help.